Hello everyone and welcome to another video in this series about the basics of C# with Unity. Today we are going to talk about methods. Methods are blocks of code that you can call to perform a specific task. They make your code more organized and reusable. As with variables, a method must be declared before it can be used. To declare a method, for example, you can write this. This method starts with the keyword void, which we'll see later. Then we write the name of the method, in this case, displayMessage, followed by a pair of parentheses. Then we add a pair of curly braces. This is where we write the instructions we want to execute. Let's test the declaration of a method in Unity. Create a new script and name it methods. Then open it in Visual Studio. We are going to create a new method. To do this, we place it inside the class, so after the very first curly brace and before the very last. And we are placing it outside the start and update methods already present, so outside the curly braces. The position of the method within the class has no effect on the execution of the code. You can declare your method at the beginning of the class, at the end, or in the middle. It doesn't matter. So I write void, then the name of the method, in this case displayMessage, then a pair of parentheses, and finally a pair of curly braces. We've just declared a new method. So for the moment, this method doesn't do anything, but it exists. I'm now going to add a statement to it so that our method is useful. I'm going to make it display a message in the Unity console using debug.log. Now let's go back into Unity to test our script. In the hierarchy, if you still have the game object from the previous video, you can delete or deactivate it. Let's create a new game object, add our script to it, and click play. We see that nothing is displayed in the console. We have indeed declared a method, but at no point we have told our program when to run it. Let's fix that in Visual Studio. To execute the code inside a method, we need to call it. This is done simply by writing its name followed by a pair of parentheses. So I'm going to call our displayMessage method in the start method. Let's go back to Unity to test. I click on play, and you can see that the message is now displayed in the console. If I call the method 3 times, we can see that the message is displayed 3 times in the console. So we've just executed the same code, the message display, several times without having to write it several times. This is one of the advantages of methods. Methods can also take parameters, which are values that you pass to the method so that it uses them. In the declaration of a method, you can define the parameter or parameters between the parentheses. Parameters are defined like variables, with a type and a name. For example, here, I can add a string parameter with the name message. Within the body of the method, I can then use this variable. Let's modify our script to test this. I add a string parameter with the name message. I then use this variable in the debug.log. We are now going to modify the method call, so as to provide it with this parameter. Let's test in Unity. We can see that the 3 messages are displayed in the console. We've executed the same method 3 times, displaying a message in the console, but with different data and therefore different results. We can also use a variable to pass a parameter to a method. For example, here, we can declare a string variable, call it message, and give it the value this message is in a variable. And now let's pass this variable to our displayMessage method. Let's go back into Unity to test. The message is displayed correctly in the console. You can set as many parameters as you like. For example, we can create a new method called add that takes 2 parameters. The parameters are separated by a comma. Let's call this method in the start method, giving it the necessary arguments. We must specify the arguments in the same order as the method declaration. So here the value 7 will be placed in parameter A, and the value 5 will be placed in parameter B. Let's test this in Unity. The result is displayed correctly in the console. Methods can also return a value. To do this, you need to specify the type of the returned value. Here, the void keyword used so far means that the method does not return a value. You can replace it with the type of your choice. For example, here, I can specify that our add method must return a value of type int. When a method returns something other than void, it is mandatory to use the return keyword in the body of the method, in order to specify what value you wish to return. The type of what is written after the return keyword must correspond to the return type of the method. For example, here, return a plus b, a and b being integers, their addition is an integer and therefore correspond to the return type of the method. The return keyword terminates the execution of the method. As the goal of the method is to return a value, once this has been done, its work is done. So any code written after the return keyword will not be executed. Let's test this in our script. Let's modify the declaration of our add method and change its return type to int. Then, add the return keyword to return the result of the addition. We no longer need the debug.log in the method. If you want to obtain the value returned by a method, you can store it in a variable of the corresponding type. For example, here I can store the result of the addition in a variable of type int. We can then use a debug.log to display it in the console. Let's test this in Unity. We can now see in the console that the result of the addition is displayed. When a method is called, you can specify which parameter you want to pass the value to. In this way, it is no longer necessary to respect the order of the parameters, as each value is given a name. For example, we could have a method that calculates body mass index and takes two parameters, height and mass. When you call this method, you should pass the height first, then the mass second, since this is the order in which they were declared, or at least the order in which they were written when the method was declared. But perhaps when you call the method, you don't remember the order of the parameters. You can then specify the names of the parameters, as for example here, when I declare mass, and height, and pass them their respective values. In this way, you can change the order in which you pass the arguments. Here we pass the mass first, then the height, whereas in the method declaration we had done the opposite. This also improves the readability of the code by giving meaning to values passed as arguments. If we compare these two lines, the first line is easier to read because you know straight away what the values correspond to. It is also possible to declare optional parameters. Optional parameters are parameters which have a default value in the case where no value is passed for the parameter when the method is called. In the method declaration, optional parameters are given a default value with an equal sign followed by the default value. Here, the color parameter is an optional parameter, and its default value is blue. Optional parameters are placed at the end of the parameter list, after all mandatory parameters. Let's go into Visual Studio to test. Let's modify our displayMessage method and add an optional string parameter with the name color and the default value of blue. Let's change the body of the method to take this parameter into account. In messages displayed in the Unity console, you can use rich text tags, like the color tag, for example. So we are going to write the color tag here, taking our color variable into account, and we'll close our color tag after the message. In the start method, we call this method several times, with or without this optional parameter. For example, a first message here, I'm going to display it in red, a second message, and I don't specify a second parameter, so this optional parameter will take the default value blue. And finally a third message, let's say in green, and here I pass the hexadecimal code of the green color as the second parameter. Let's go into Unity to test. We see that the messages where we specify the value for the optional parameter did indeed take the specified color. On the messages where we didn't give a value, we used the default value, blue. To add color to our message, we added a rich text color tag with a concatenation of strings. This makes the line not very easy to read. Instead of concatenation, we can use a string interpolation. In other words, inserting the value of an expression directly into the string. To do this, we add a $sign in front of the string, and inside the string, we can add expressions between curly braces, like our debug.log line here, with the rich text color tag around the message. Here, we have used our variables color and message, and we've put curly braces around them to show that this was a string interpolation. I find it makes the code more readable, but that may be a matter of personal preference. Choose the method you are the more comfortable with. It is also possible to create method overloads. This means declaring other methods with the same name and the same return type, but with different parameters, which can be different types or different number of parameters. We can test this with our displayMessage method. Rather than using an optional parameter, we can declare this method twice. The first time with just the message as the parameter, and the second time with both parameters. This time we don't use an optional parameter. When the method is called, depending on the parameters supplied, our program will select the method that fits best. Let's test in Qt. We see that only the calls where we gave a color changed color. To recapitulate, to declare a method, we start by writing the method's return type. If the method returns nothing, we use the void keyword. Then we write the name of the method, followed by a pair of parentheses. Parameters can be added between these parentheses. Parameters have a type, a name, and can be optional. Optional parameters are placed at the end of the list. Finally, curly braces are used to enclose the instructions to be performed by the methods. The return type, name, and parameters together form what is known as the method signature. The curly braces and the instructions they contain form the body of the method. And that's it for this video on methods in C#. I hope you found it useful. In the next video, we'll talk about comparison operators and how to use them to make comparisons between values. If you have any questions, don't hesitate to ask them in the comments. Thanks for watching and see you next time.